Okay, so my first pitch is a Rube Goldberg simulator. So a Rube Goldberg device is a contraption that is over-engineered and over-complicated to move an object from point A to point B. So you're making, and often it's a ball traveling through space, and you're making it go through all these hoops to get to the end, as opposed to just throwing it in the basket, right? So it's an over-engineered system, and you can see from the picture that I've got, that gives you sort of a silly example of a Rube Goldberg machine where it starts off with a glove punching the bowling ball that sets off a chain reaction and gets to the end of the Rube Goldberg machine. So some of the games out there, probably the most famous one is Incredible Machine. There was Lemmings in 1991, which is sort of Rube Goldberg-esque. If any of you guys played Lemmings, it was keeping animals alive. So you would win the level if, I think, one lemming survived by the end of it. If all your lemmings died by the end of the game, you had to restart that level, you had lost. So as opposed to getting an object from point A to point B, it was more about protecting these animals. So you were building Rube Goldberg-like contraptions, so these lemmings, and they were called lemmings because all they did is walk in one direction, whether it was to their imminent doom or not, would just do very simple tasks. So you had to stop them. You had to find different ways of stopping them from killing themselves. The lemmings were their own worst enemy. And in 2014, the Incredible Machine team went and remade it for Contraption Maker. And that was done on Steam, on the PC. So it's multidisciplinary by design. So in various contraptions in the Rube Goldberg machine, we can teach concepts about chemistry. So we can have like water that gets, you can combine fire, it boils, boiling water creates steam. The steam starts a generator, the generator turns a pulley system that then sends the ball off, right? So we can teach concepts like chemistry, we can teach concepts like physics, certainly Newtonian, the three Newtonian principles are going to be apparent in a statement like this about objects staying in motion, transference of energy, and opposite forces reacting when two objects collide. Or when a force of one object applies to another object, there is an equal and opposite reaction. So we can do all of that in a Rube Goldberg machine. There's mathematics. We can do silly things like have a scale that tips when a certain number or a certain fraction is reached, so we can teach mathematical concepts. We can teach mechanical concepts. We can create switches, levers, pulleys, all kinds of mechanical engineering concepts to solve puzzles. We can do basic programming. So we could even have different systems that are programmed. So if the red ball comes in this side of the machine, we can program so a yellow ball goes out the top or a green ball goes out the bottom. We can make conditional statements that have some programming concepts that sort of teach a bit about robotics and programming. We can do biological concepts. There's no reason why we have to stay in the land of, the Incredible Machine is everything in our size, real life size, so basketballs and mice and stuff like this, right? But we can do the Incredible Machine with subatomic particles, right? We can go right down to the size of a cell and have these type of reactions happening on a microcell, or the opposite, we could zoom way out and do planetary things. It doesn't have to be Earth scale objects, right? We can do earth sciences, so we can have systems where there are cyclical systems. So we could have a large body of water that generates clouds that comes over, rains, fills up a cup, tips a scale, creates a chain reaction. And we can create whoa, sorry, that was my fault. I tripped on the cable. Okay. We can create simple logic devices. So we can program AND gates or OR gates into some of the objects where they would act as logical gates, teaching a little bit about computer science and hardware. And of course, the list is endless. I think pretty much any scientific concept you could probably figure out some way of including it in a Rube Goldberg attraction. I think that's both the strength and the weakness of this idea is that it's kind of open to everything, and that's why that's a good thing, and that's why it's a scary thing. So I was thinking of how we would have it played by people in a circle around the screen play area. So I thought we would involve 4 participants. So we'd have various contraptions on 4 sides, encouraging all 4 people to go in and build the event. There would be a specific goal, And we could either do a turn-based or real-time play. So I like the fact that you're doing a turn-based play because it forces the students to posit a theory of what's going to happen. Oh, if I put this here, then this is going to cause that. That's going to cause this. So they have to plan it in advance. Whereas real-time, if we have them able to edit things as it flies, you do a lot of guessing, right? You can do a lot of things where you're not actually thinking through the problem, you're just reacting to it, right? So, my preference would be to go to turn-based, but there's nothing stopping us from trying both or doing a real-time one as well. There's lots of chances for scoring. We can score fastest completion time. We can track it individually for that school. We could even upload it to a website and track it nationally, right? And say, how fast did this class do against the national average of time it took? We can score the fastest, so I said fastest completion time, so that's completing the puzzle fast, and the fastest run time would be to achieve the goal. So what was the shortest path from this pressing the start button to it reaching the goal, right? So it might have taken you 50 attempts to get there, but that 50th attempt was the most efficient way of solving that problem. We can do the least amount of time to solve puzzles. So we could set a timer and have them solve as many puzzles as they can in a set time. And we could baseline these versus average time and give them feedback. You were slower than the median, you were higher than the median. We can baseline these times and give them context. I think we'd have lots of fun with failure states in the game. So we could have like an object, we had to get a car from point A to point B, and the entire edge of the play surface is a cliff. So if the car doesn't make it to its intended location, it inevitably will fall off the edge of the world, which will be a car flying off the cliff. And as you can see in my pictures, I'm a bit inspired by Toons' The Cat, if you ever watched Saturday Night Live in the 70s or 80s. I'm dating myself, but it was a very funny skit. It always ended with the cat driving the car off the cliff. That's the only way the skit ended. So I thought we could have lots of fun with interesting deaths. We could have the area surrounded with lava, the area surrounded with water, the area surrounded with electricity, all of the game tropes of instant death if you fall off the edge of the world. So that's my idea for the Rube Goldberg machine.